I love it.
As a reminder, I don't typically like to stop in the middle of an example. So we had just started talking about critical numbers yesterday. And what this is leading into today, guys, what this is leading into you're worse than my Algebra 2 classes. I just want you to know that.
I don't think that was meant.
No. This semester, my Algebra 2 classes are productive. And this class is not right now. Okay. They're not early in the morning. So on here, we just started talking about critical numbers. This is all leading into if I give you a function and I ask you to find the absolute max and min. We had talked about how we start to look at the critical numbers where the derivative would be 0 because that could be a local max or min. Could be. Doesn't mean that it actually is. Or where a derivative doesn't exist. So the example that we were working on, we had said we need to find where this function f is equal to 0 or where the derivative is equal to 0, where the derivative does not exist. We had determined it's a product, so we were using the product rule, and that's what we had here. And then we were starting to simplify this because I said here's a case where you don't just want to leave your answer the way it is, because when you have to solve to see where it is 0 or where it doesn't exist, that can be very difficult if you're not simplifying it. So we had factored out an x minus 4, and then we were in the midst of simplifying this, and we had distributed here this 4/5 x to the negative 1/5. So from here where we had stopped, I think I had mentioned this, but we had just stopped here. So we do have these two like terms. They are both x to the 4/5. So we could combine those. Let's see, 2 would be 10/5. So we would have, probably use the same color pen here, 14/5 x to the 4/5, and then minus, I'm going to write this right away as well since it is x to the negative 1/5. I'm going to write that as 16 over 5x to the 1/5. We still do have the x minus 4, that factor in front. And then, again, we're trying to find where this is equal to 0 or where it doesn't exist. So where I'm trying to head with this is we could right now set this equal to 0 to see where it doesn't equal 0 or where it is equal to 0. We had talked about how x minus 4 being a factor, we would then set that equal to 0. 4 is going to be one of the critical values. And then we would have to set this equal to 0 as well. It's easiest if you have separate terms that are fractions like this, specifically because this has a variable in the denominator, if you can get this to just be one fraction. So what I'm actually going to do here is both of these do have a denominator of 5, so I'm going to multiply this by x to the 1/5 over x to the 1/5 so that these have a common denominator. So this would really be, and I'll rewrite this up here. Didn't leave a ton of room on here, sorry about that, but this is 14x to the 4/5 over 5, so if I multiply by x to the 1/5 over x to the 1/5, and that way my two denominators would be the same. So then I still have the x minus 4. On top here then, the x to the 4/5 times x to the 1/5, add those exponents would just be x. So I would have 14x over 5x to the 1/5. And then it would be minus 16 over 5x to the 1/5. So I'm just going to combine those right away as well and just put 14x minus 16 over 5x to the 1/5. So this is our derivative. And this is a more complicated function. So if you did look at any of these problems last night, the ones towards the end that were asking for critical numbers, they're not all necessarily like this. So for this function, to find where it's equal to 0, I'm just going to put f prime of x equals 0. That's one thing we want to check for. The other thing we want to check for is where it would not exist, where it would be undefined. So where it's equal to 0, that would be, in this case, since we have two factors, it would happen when x minus 4 equals 0, like we talked about, so when x is equal to 4, or when this fraction is equal to 0, and if a fraction is equal to 0, what makes a fraction equal to 0, I should say, the top. So it would just be, the other case then would just be when the 14x minus 16 would equal 0. So x would equal, 16 over 14, so 8/7. So positive 4 is a critical value, 8/7 is a critical value, and then those are the only two x values that would make the derivative equal 0. A lot of derivatives don't have x values where they don't exist. Finding where it doesn't exist would be finding values of x that are not in the domain of the derivative. So why I was trying to get this to be one fraction here is when you have a fraction, it's equal to 0 if the top equals 0, it's undefined if the denominator equals 0. So then this derivative will not exist if 5x to the 1/5 equals 0, which would mean x would have to equal 0. So there's three critical values, 0, 8/7, and 4. So those would be possible x values to check to see if an absolute maximum would occur, because they could be where local maximums occur. Okay, so are there questions on that? If your derivative is a polynomial, it's going to exist everywhere. So in that case, you're just checking to see where does it not, or where does it equal 0. So not every, like I said, not every derivative will have a value where it doesn't exist. Okay, so where this is all leading, as I said, so now I'm looking at the sheet that I just gave you today, but we're going to be using the critical values we talked about yesterday. And because we're kind of going between the two lessons, what I just had at the top as kind of the second day starter here, it says just for a continuous function f on a closed interval, where could an absolute max or min possibly occur? We talked about this yesterday, and I'm just going to highlight this condition here. So we had just talked about how for a continuous function f on a closed interval, we could have an absolute max or min where we have a local max or min, which could occur at, that's the whole reason we're finding critical values. Those could be local maxes or mins, which could then be absolute maxes or mins. So I'm going to put these could occur at a critical value, and that would be where f prime of x equals 0 or f prime of x does not exist. And then we did talk about this. It was in the midst yesterday of some examples and ideas we were talking about. But if you have a function on a closed interval, aside from a local max or min on that interval, where else could you have an absolute max or min? On the ends, yes, at an end point. So this is using the extreme value theorem we talked about yesterday. Says that every continuous function on a closed interval has an absolute max and an absolute min. This is now how to find it. It's called the closed interval method. That's just the name of it. But it says to find the absolute max and min values of a continuous function f on a closed interval from a to b. You want to find the x values at which those absolute maxes and mins could occur. So you're finding the values of f at the critical numbers of f, so find the critical values, and then evaluate the function f at those values. find the x values that are the endpoints and evaluate the function at the endpoints of the interval, and then whichever is the largest value is your absolute maximum on that interval, whichever is the smallest is the absolute minimum. So it's more or less just knowing where to look for these. So we have two examples of just doing this on the front here. So we're finding the absolute max and the absolute min. We're going to go through the first one together. So we have f of x is x cubed minus 3x plus 1 on the closed interval from 0 to 3. And how I typically start these, we already know the endpoints are 0 and 3, so we need the critical values. So we need to know where is the derivative 0, where does the derivative not exist if there is a value where it doesn't exist. So we need to know what f prime is. And what would f prime of x be? Okay, so then we have our derivative. Find the critical values. So find where f prime of x is equal to 0, or where f prime of x doesn't exist. So where does it equal 0? Set it equal to 0, solve for x. So it'll equal 0 when, if I add 3 to each side, 3x squared equals 3. So we have x squared equals 1. So x could equal 1 or negative 1. But now here you also want to check, you're on the interval from 0 to 3. Are these values in that interval? 1 is, but negative 1 is not, so you can disregard negative 1 because it's not on the original interval. Okay, so we have a critical value of 1, and then is there anywhere where the function 3x squared minus 3 doesn't exist or is undefined? No. So there's no values here that make it undefined. So then once you have your critical values, in this case we just have the 1, and then your two endpoints, you then evaluate the original function at those x values. So now I'm going to find f of 0, f of 1, and f of 3. So an absolute max or min can occur at a critical value or at an endpoint. And so then I'm just finding which of these three function values would be the largest, which would be the smallest. That's my absolute max and my absolute min. And then as a reminder for you too, if you have your graphing calculators handy, depending on how many function values you have to find, you could make it easier on yourself by just typing the function into y1 or into one of your y's under or in your list there. So we have x cubed minus 3x plus 1, and make sure too that you are substituting these values back into the original function and not into the derivative. And then I think a lot of you at this point already have your table set so that when you go to table, you're actually typing in the values. I just have a lot in here from the last time I used it. And if you want to delete them, you have to hit delete for everyone. You can type over them though, I just wanted to clear it. Okay, so then I can type in 0, 1, and 3, and it'll give me those y values right away. And if you do have decimals, you can highlight them to see more decimal places. So f of 0 is 1, f of 1 is negative 1, f of 3 is 19. So from here, I can see then the absolute max is f of 3 equals 19. The absolute min is f of 1 equals negative 1. And I know this is how I usually write it. Make sure you understand that the y value is the actual maximum and x value is just where that is occurring. Okay, so I would like you to do number 2 for that function f of x on the interval from 0 to 3. Find the absolute max and absolute minimum. I will give a helpful hint because I know when you're given a quotient, some of you like to then write it as a product instead and use the product rule. It's going to be easier simplifying if you leave it as a quotient and use the quotient rule. Because then it's already a fraction versus doing the product rule and then trying to make it a fraction. So just a helpful hint for that. Because you do need to simplify it, it's easier if you just leave it as a quotient. Yes, yep, do not distribute the bottom, leave it in its factored form. Yep. Because this only works if this is 0. So factoring and setting it equal to the other side only works if it's 0. You don't need to FOIL this out. Yeah. So if x squared plus 4 squared equals 0, that means x squared plus 4 equals 0.
They left it, 'cause I
No,
still,
real
I still
numbers.
got that. But then,
It was not the right answer. Yes. Just make sure that you state them. What the absolute Did you get 2 for the other one?
Marty.
What's the question? Yeah. Negative x squared plus 4 for the top. Yeah. We did this yesterday.
I don't know why.
Because yesterday was more of why we're doing what we're doing today. It was understanding why we're doing it.
I'm more of a short term.
Well, you have to understand the concepts. All right. I think you're all good. Just double check. Make sure also you got there correctly. So check your derivative. You can always leave, when you use the quotient rule, always leave your denominator in its factored form. You should never have to FOIL expand that out. And you're just simplifying the top, which is 4 minus x squared, or negative x squared plus 4. Critical values would be 2 and negative 2, but negative 2 is not on the interval. Denominator, I've said this before, you do not deal with imaginary numbers in calculus. So the denominator would have imaginary solutions where it's equal to 0. So because there's no real answers, you don't have to worry about it. Did you have a question, Megan, or was that your question? Okay. Yeah, so if you see that you're going to get an answer but it's imaginary, you just disregard it. You do not have to deal with I in calculus. You deal with real numbers in calculus. An imaginary number is not real. And then also make sure that you're not just leaving this as your answer. If you just have this, everything is correct, but you have not answered the question. So make sure that you are saying what is the absolute max, what is the absolute min. Okay, questions before we go on to the last example? Okay. So the last example, we have the Hubble Space Telescope was deployed on April 24th, 1990 by the Space Shuttle Discovery. A model for the velocity of the shuttle during this mission from liftoff at t equals 0 until the solid rocket boosters were jettisoned at t equals 126 seconds is given by, here's again the velocity. So I'm just going to write after this, the interval is 0 to 126. And then it says, using this model, looking for my highlighter here, estimate the absolute max and min values of the acceleration of the shuttle between liftoff and the jettisoning of the boosters. And again, liftoff was t equals 0. The jettisoning of the boosters was 126 seconds. All right. In order to estimate the absolute max and min values of the acceleration, what do we need to find? The derivative, yes, of the velocity, because that gives you the acceleration. All right, so the derivative, we would need to multiply 0.001302 by 3. So 0.003906 t squared, and then minus 0.18058 t plus 23.61. Okay? Now, read the question again carefully. We're estimating the absolute max and min of the acceleration. So to find the absolute max and min of acceleration, we need now the derivative of acceleration. So you are not finding where this equals 0. If you find the critical values of acceleration, you're finding max and min of velocity. So to find max and min of acceleration, you need a prime of t, the fourth derivative, technically. Yes, it'll give you an easier equation to solve, that is for sure. So let's see, 0.007812 times t minus 0.18058 would be the derivative of acceleration. And we have our endpoints. We need our critical values. So because, again, this is a polynomial, I know it exists everywhere. It's never undefined, but I need to find where it equals 0. Okay, so T will equal 0.18058 divided by 0.007812. And part of why I included this as an example is to point out, I think I've said it before, you do not want to round a value in the middle of a problem. So do not divide these and round it to 3 decimal places. So you would either leave it written like this, or you could, I think I've showed you how to do this before, you could store this in your calculator. Okay, so I'll show you how to do that again. On your calculator, so if you do type this in, or if you have, you can just leave it on your screen. So type it in, get the decimal, and then right above the on key, you should see the store key, STO with an arrow. So if you hit that, it'll take your previous answer and it'll store it, and then you want to hit the green, well, it's green on mine, the alpha key, and then whatever letter you want to store it as. So because it's up to you, because I have T here, I'm going to store it as T, but it's up to you what you want to store it as. Let's see. So I'm going to store it as T, hit enter, and now anytime I type in T, if I do alpha 4 for T and hit enter, it'll give me that value. Now, thinking for free response questions on the AP test, so if I put in my work, if I put this and I say store in calculator as T, now anywhere in my work I write capital T, they will know what value I'm talking about. So you don't have to keep rewriting this whole thing. You can just write whatever letter you stored it as, and they will know, okay, this is what they did, this is how they got their answer, that's okay. So then, this is the only critical value we have, because again, it exists everywhere. So then, to find the absolute max and min of the acceleration, I would need to evaluate the acceleration at the 2 endpoints, 0 and 126, and at this value. So I need to find A of 0, and this is what I mean by writing the variable. I'm going to find A of T, and so they know what T means, and then A of 126. And make sure you're substituting the values back into A, which was V prime, so not going back to the very original function that you were given. So I'm going to type A into my calculator here. And it'll even let you, so I went to my table. Here, I'll actually delete these. So even if you go into your table, so I can type in 0, and if I want to type in T again, I just type in alpha 4 for T, and it will substitute it into the table. And then 126. And now these values, these are going to be my final answers. I can estimate these or round them to how many decimal places? 3, unless you're given less than 3. So for example, at 0, it's just 23.61. And then again, you highlight in your table, if you're using this feature, highlight the number, because then it'll show more decimal places on the bottom. You're not just limited to what they have in the table. I know they're giving you 3, but sometimes they don't. To 3 decimal places, yes. And then this was 62.869. All right, so then max and min for the acceleration. So I could say max acceleration is a of 126, 62.869. What would the units be on the acceleration? Say that again.
You need the answer for the
Velocity is in feet per second. So it'd be
Oh,
feet per second squared. Well, you're given units, so you should include units. And then the minimum acceleration is a of t. Again, they know what t is, 21.523 feet per second squared.